So what is weight? Weight is essentially this force due to gravity. We're saying any two masses pull on one another towards each other. It is an attractive force. Okay? Now, with weight, it is essentially this force, but we generally refer to this force as being the weight when one of the masses is, in our case, Earth. Does our weight vary? Yes, it does, because any change in the mass of either one will cause a change in this force, which is the weight, and any change in our position away from the other mass will cause a change in force. So let's start off with the most basic. If we've got Earth and we are at the surface of Earth, then we're going to experience a force towards the center of Earth, which we generally refer to as the weight. Now, if we move away from Earth, say in outer space, therefore increasing our distance from the center of the Earth to our center of mass, yes, therefore, if we're increasing the distance r, then we are going to experience a smaller force. Therefore, we're going to experience less weight, less pull towards Earth. But it doesn't stop there. Even on the surface of Earth, the weight is not constant. There are three main reasons why our weight would actually vary. Number one, Earth is not uniform in terms of density. Secondly, Earth is not spherical. Actually, due to its spinning, it has somewhat flattened at the poles and got a bit wider at the equator. This is approximately 6,350 kilometers in terms of its radius, whilst this radius is approximately 6,372 kilometers. So there is a bit of a difference there also. Where will you experience the larger weight? At the poles or at the equator? Well, where do you have the largest distance? Where are you going to have the larger distance away from the center? You're going to have the smaller force. And the larger distance is always going to be, therefore, at the equator. Third point. Earth's rotation also affects the amount of pull that we actually experience. And this is somewhat of a more difficult concept that students generally find a bit more difficult to understand. So let me try to explain this very quickly. So any object that's spinning, that's performing circular motion, we know experiences a centripetal force, a force towards the center. Now this you should know from the previous topic of circular motion. When you've got a force, there's going to be some acceleration towards the center, which we refer to as the centripetal acceleration. So as far as mathematical equations here are concerned, the centripetal force is given by mv squared all over r. We do know, however, that when you've got a force, there's going to be acceleration, so that force we can replace by ma, and therefore you get such an equation, and this would be the derivation for the equation. Such a motion, such a circular motion, requires some acceleration towards the center. Now, when people are at the equator, or anywhere on the Earth's surface for that matter, but at the equator, you're going to have the largest velocity, okay? And with the largest velocity comes the largest force. And with the largest force comes the largest acceleration, okay? Larger velocity means a larger acceleration. So any object at the equator where the spin is largest, obviously compare that to the poles where objects are just rotating on their own axis and they are not actually spinning round. Where you've got the largest velocity, then you're going to experience the largest acceleration, and that means that from this gravitational acceleration, which is 9.81 meters per second squared, some of that will actually be used to generate a centripetal acceleration. Some of this pull that Earth is actually exerting on us is going to be used to generate the centripetal force. That leaves us with even less acceleration due to gravity, and therefore we feel less attracted towards Earth at this particular point.